First of all, we have Docker search command. It is used to search images from Docker Hub. Just to clarify, you don't need to have a Docker Hub account to search repos from your host or even pulling them. It is just a requirement to use the web interface of Docker Hub or for pushing repositories on it. As for the syntax of this command, the phrase Docker search is followed by the name of the image and optional version number after colon. Let's execute this command. Here, we get a list of Python images sorted by the number of stars. Of course, many of them are frameworks built on top of Python, since Python would be one of the keywords. There are descriptions of images to provide more brief insight and a check of whether the image is official or not. Here, the first image has the most stars and it is also the official image. Next, we have quite a special case. Docker search registry command gives official image of Docker registry from Docker Hub. If we don't want to get such a long list of repositories, we can also put filters on our search. Here we have put filter is-official equals true, which will only show us the official images. There we go. We only got one image. Sweet, right? For those who like their results neat and tidy, Docker also lets you format the results of the search. Here, the format is mentioned in double inverted commas and it starts with the keyword table, which means we want a tabular format. Then we have entered the desired fields that we want. The fields are mentioned in double curly braces and they are separated by \T, which stands for tab or space character. You might have guessed by now that this will create 3 columns, one of each field. Now that the predictions and wish lists are done, let's run the command. There we go. Our crowded little table is here and it is showing the same repositories as before, just in visually different format. Also notice that we only have 3 fields that we had mentioned in the command and rest of the fields are skipped. Moving on from Docker search, we have Docker images command. It is a shorter version of Docker images ls command and both of them do exactly the same thing, which is list out the images on your host. As you can see, these are the images that we built during our previous section. On the other hand, if we want to list out versions or instances of particular type of image, we can mention the image name followed by Docker images command. Let's try and list all our Ubuntu images. Here we can also see the size of the image, which denotes the size they currently occupy on the storage of host machine. Of course, specifying the version number preceded by a colon narrows down the list just to one entry. Furthermore, if we want to see the full parts of truncated data like image ID, we can use --no-trunc flag as well, but be cautious while using it since it can make the results messy. Really messy. Then we have Docker pull. It pulls the specified image from Docker Hub to our Docker host. Here we have provided nginx with latest tag. So whichever image will have the latest tag on Docker Hub's nginx repository will be pulled. As you can see, it has downloaded a newer version of nginx, which is latest. Instead of latest, if we use nginx:alpine, Docker Hub will provide an image with alpine tag. Now, if we grab a list of available nginx images on our host, we get 2 of them. First is the alpine one, which we just pulled, and second is the latest version. As you can see, both of them vary majorly in terms of size. Alpine is like minimal nginx image, which is smaller in terms of size, since Alpine as the base OS itself is smaller. Finally, if we want all variants of nginx images, say for testing purpose, we can hit the command with --all tags flag and we will receive the missing images from the repository. Once we list the Nginx images now, it is clearly visible that these are different versions with different sizes. We are back to our Docker Hub dashboard. Let's click on Create Repository option so we can make a repo and push images to it. On the left pane, Docker is generous enough to list out the steps to create a repo. First of all, we are supposed to provide a namespace for our repositories so that we don't have to make the name unique across the globe. Generally, namespace is same as the username. Now, let's name our repository. We are naming it repo-nginx. You can name it anything you like. Next step is the description of this repo. Here, as you can see, we have given a short and sweet description about this repo. If you want to describe your repo in much more detail, you can jump to the full description section of this repo, and in the final step, we can set the visibility permission for our repository. Docker offers one free private repo and unlimited public repo with free Docker Hub account. So, do your choices wisely. We don't need private repos for now, so we will select the public visibility for this repo. Now let's create the repo by pressing Create button at the end of the page. We have successfully created our repo Nginx. As we can see that there are some tabs above the short description of the repo. First one is Repo Info tab. It displays the basic information about our repo Nginx, such as its visibility, which is public, and short description about it. Second one is tags. You can add multiple images under a single repo separated by different tags. If you do not specify any tag for the image, it will by default take latest tag. Third one is collaborators. It consists of a user or a list of users whom the owner of the private repo wants to grant the read, write, or admin access. Next, and the fourth one is webhooks. Webhook is a HTTP callback post request. It can be used to notify user, services, or other applications about the newly pushed image to the repo. Last one is the settings of the repo. Here, user can change the visibility permission of the repo and can also delete the repo from user's Docker Hub account permanently. Now, as you can see, you can pull the images available under the repo Nginx repository by using this specific Docker pull command, docker pull cerulean canvas / repo-nginx, and store them on your machines. Since this is your first ever repository created on Docker Hub, let's self-indulge ourselves by giving it a star. Starring a repo is a way to show that you like the repository and you can remember it for your future references. Now let's switch back to the terminal. Before pushing an image to Docker registry, we need to log in again to Docker Hub using docker login command interactively. Here, we have been asked to enter our Docker Hub login credentials. We will enter our username, which is cerulean canvas, and its password. We have successfully logged in our account with a warning which says that our Docker Hub password is stored unencrypted in config.json file on our machine for future references. We are okay with it for now, so we will ignore the warning and proceed to the next step. Now we will tag a local image nginx:latest into a new image. We will specify where we want to push this image. We can write the host name on which the registry is hosting, which is cerulean canvas for us. Now we will mention the registry name in which we want to push the image, that is repo-nginx. You want to give your own custom tag to the image, such as cc-nginx for this example. Or if you don't mention any tag for the image, it will take latest by default. This two-stage format is mandatory to push an image to a public repository. Now let's check out our newly tagged image by listing all images on our machine. There you are. we have original Nginx latest image and newly tagged Cerulean Canvas /repo-nginx:/cc Nginx image. But did you notice something? These two images have the same image ID. It is because docker tag command has created an alias for your image as its new image name, so that the original image will be untouched and all of its changes can be performed to the new aliased image. Now let's push the Cerulean Canvas /repo-nginx:/cc Nginx to our repo Nginx using docker push command. We have already specified the path for the destination location in image name. As we can see, Docker is pushing each layer of the original latest image at this end. On the other hand, Docker daemon will stack all of these layers sequentially and create a new image with the tag cc Nginx in the repo Nginx. At the end of the process, we got our new image digest identifier of the push image. Now let's switch back to Docker Hub account to verify that our repo has been successfully pushed. We will navigate to the repo Nginx repository, go to tags, and we have successfully pushed the image. Image tag, size, and updated name are mentioned here. In next lecture, we will dig deeper into the image by inspecting it and looking at its history.